Okay, so moving on, we're getting into the digestive system processes and regulations. So we're going to talk about the fundamental activities the digestive system engages in, talk about some examples, we're talking about functions of these organs, and then we're going to talk about mechanical versus chemical digestion, as well as peristalsis and segmentation. These are things that are somewhat similar, but have some very key differences that we need to be aware of. So we look at the 6 fundamental activities. And if we think about it, they're kind of going, for the most part, in quote, order. Ingestion, right? You got to put the food in your mouth in order to get the nutrients from it. Propulsion, which means moving it, right? Move that food down the line. Mechanical digestion, which is to physically break food down. Chemical digestion, which is to break the food down on a chemical level. Absorption, bring in those nutrients, and defecation. Get rid of anything that we cannot use. So we look at the mouth and we work our way down. What are the functions of the mouth? It's to ingest the food, right? Because I hope you're not shoving the food anywhere else. You should only be putting it in your mouth. But we're going to chew and mix the food together, and this is where we're going to start chemically breaking down the food and physically breaking down the food. The act of chewing is going to physically mash up the food, break it into smaller pieces. It's also going to help mix things like saliva in with it, which that saliva contains enzymes to help break down, like amylase, to break down carbohydrates. It will also start the breakdown of lipids with lingual lipase, and then we'll move that food to the pharynx to start the swallowing process. With the pharynx and the esophagus, movement, that's our goal. Take the food from one organ, one region to the next. Simple, simple, simple. Now we get to the stomach. The stomach is a big player here because the stomach's going to do, again, more mechanical and chemical digestion, as well as kind of serve as a pacemaker, so to speak, of the digestive process. So the stomach is going to take the food that we've eaten, it's going to mix it and churn it together, mix these gastric juices in with it, and we're going to form what's called chyme. And we're going to start another chemical breakdown process, this time of proteins. So we've already started breaking down some lipids, we've already started breaking down some carbs, we've already started breaking down some proteins. The stomach will then slowly empty, slowly releasing food into the duodenum in the form of chyme. We can absorb some things that are fat soluble, so things like aspirin, as well as alcohol. Right? This is one of the reasons why some people, like, if you drink while you're eating, or you drink before you're eating, right, you may feel like you get tipsy faster because you're actually absorbing it in the stomach while some of the food you're eating is getting absorbed in your small intestine. We also have some antimicrobial functions. One of the big things is the fact that our stomach has an extremely low pH. It has a pH of about 2. So it's going to be really difficult for any sort of microbe to survive in that harsh environment. So as we are released from the stomach, we enter into the small intestine. This is going to mix that chyme with more digestive juices that can chemically break down the food. We're also going to slow the rates of movement down, right? So we're going to propel it at a much slower rate. The reason being, we want to actually fully digest it and absorb it. If it moves through the small intestine very quickly, we're going to miss a lot of the key nutrients we're trying to get. This is also where we're doing the absorption. So once we have these digestive juices added in, we have chemically broken down the food into the simplest of carbohydrates. We've broken down proteins into their amino acids, lipids, nucleic acids, right? We've broken everything down, released vitamins and minerals, and we can absorb that now. We'll also perform physical or mechanical digestion via segmentation, which we'll talk about in a bit. We look at the colon, we're going to further break down any food residues. We will then get some water out of this, electrolytes, and there are some vitamins that we will get here as well, mainly vitamins that are produced by the bacteria that live in the colon. So the bacteria that live in the colon can kind of, utilize some of these waste products we're creating, and then they can create vitamins that and release vitamins that we actually like and we want to use. And then the colon will propel the feces forward towards the rectum for elimination. If we look at the accessory organs, we look at the liver. They're going to be responsible for producing bile salts, or bile as it might be known by. These are going to help emulsify lipids, so basically help break down fats to some degree so that we can actually absorb them. The gallbladder is going to take that bile, the bile salts made by the liver, store it, concentrate it down, and then release it as it's needed. And the pancreas is going to produce a variety of digestive enzymes for all different types of chemicals, and then also bicarbonate to help neutralize the stomach acid once that kind gets into the small intestine. So let's talk about motility and propulsion. This has really two parts, which is swallowing and peristalsis. So swallowing is pretty straightforward, but peristalsis you might not realize or might not remember, or maybe you've never heard of it. But peristalsis is just a rhythmic, wave-like muscle contraction. So like we think about the esophagus. If you go to swallow, you push the food to the back of your throat, and then you consciously swallow. But after that, it moves down. If you've ever taken too big of a bite and swallowed it, you've probably felt it, right? It's uncomfortable, but you could feel it moving down your throat. That feeling of it moving down, right? You're feeling peristalsis that you don't normally notice. But it's a rhythmic, wave-like motion of muscle contraction to force that food down towards the next organ. When we get to mechanical digestion, we have mastication, which is a fancy word for chewing, and segmentation, which this is going to be a process that your small intestine takes care of. So here's just kind of what we see, what's happening and where. So we see mechanical digestion, the chewing, right, mastication that's happening in the mouth. We have propulsion, because we're going to push it back to swallow. Peristalsis as it moves down the esophagus. More mechanical digestion as we churn in the stomach. Chemical digestion also begins there too. We have a little bit in the mouth. We don't have that on the picture here, but it does happen there too. Then we get in the small intestine. We have all of these happening, right? We are moving things forward, chemically breaking it down, mechanically breaking it down, and absorbing. And then finally, we are going to get a little bit more absorption with water, keep propelling it forward. We're not doing any sort of chemical digestion anymore when we get to the large intestine because we've already broken it down. We're just going to mechanically churn it and then form the feces before we eliminate. If we look at the regulatory mechanisms, we have the neural controls as well as hormonal controls. We talked a little bit about the neural controls. I'm not going to get super crazy detailed here, mainly because that is more physiology. But we do have some hormones like leptin and like somatostatin that will help us with things like feeling full, knowing how much we've eaten, making us feel hungry or making us feel sated, like we don't need to eat anymore.